So next up, really excited to introduce Josh Liberty, and he's going to be talking about building better hunt data. So Josh has over a decade of experience in threat detection and incident response, and currently he works at Brex as a senior security engineer. I also wanted to point out his bio picture had a super cute dog in it. So Josh, I hope that you posted a picture or maybe pictures of your dog in the pet channel for everybody to view. So throughout this summit, we've been talking a lot about data and collecting data and how to look through that data and how to hunt through that data. But we're going to take a step back in this presentation and really talk about the importance of the quality of that data, because there's this concept of garbage in, garbage out, right? And so many times I've worked a case and maybe an examiner has kicked off a search and they've looked for something and they come back and they're like, well, I don't see any evidence of SQL injection. I'm like, well, did the logs cover the time frame that we're talking about that went back 3 months? And there's kind of a pause and you can kind of see, okay, maybe I better go back and double check that. So I think this is a really important talk because we're basically talking about the foundation and things that we do before we even get to that threat hunting to make sure that we've got a great foundation for it moving forward. So I will go ahead and turn it on over to you.
Awesome. Thanks, Mary. That was a great introduction and really just starts to talk about the importance of establishing the foundation of having good data when you hunt. And that's what I hope everyone takes away from this talk. Mary already introduced me, so no need to do that. The talk is called Building Better Hunt Data. The agenda for today's talk is essentially all things data. That's good, bad, the ugly of it all. What I'll be discussing is how we should evaluate data quality when we hunt, why we want high quality data for hunting, the signs of low quality data, or said another way, how your data quality could be improved. And then we're going to spend a lot of this presentation looking at ways to improve data quality in how we build our systems, and specifically building systems to get control of your data quality. Yeah, Mary, I mean, you nailed it. I had to put a picture of my dogs here instead of a photo of myself, talking about my background. As Mary mentioned, I've been working in detection and response for just over 8 years, approaching a decade. A lot of that time has been spent in threat hunting. A lot of that time has been spent in building systems to scale detection and response. I work at Brex. I'm a security engineer on their detection and response team. And Sands has, very helpfully set up the Slack hallway channels for questions after the talk and during the summit. But, if you want to reach out to me later, it's great to do that on Twitter. I use the same handle on GitHub and Medium as well. So feel free to reach out to me if you prefer. I also like to start my talks by just kind of giving you an idea of the goals for the talk. So whether you're a threat hunter or a security or data engineer or a security leader, the goal for this talk is to get you thinking about the quality of your data. Would you say it's good? Could it be better? Have you done everything you can to make it the best it can be? That's what I want you to think about and take away from this talk. So our first topic is evaluating data quality. And said another way, you can think about this as a question, which is, what is good data? And so what we have listed here are 6 dimensions of data quality that are pulled from the Threat Hunter Playbook. And these are actually referenced from a Department of Defense white paper that discusses data quality. And the answer to the question is kind of simple in the context of these dimensions. If your data is accurate, if your data is complete, if your data is consistent, then it's good data, and said another way, is high quality data, or more likely to be high quality. If you think about your data with these dimensions or criteria in mind, what it's going to result in is data that is more reliable, data that is more trustworthy, and data that is more available and highly usable, which are all things you want when you're hunting. So with those in mind, let's talk about the benefits of high quality data, or, said another way, this is why I want high quality data when I'm hunting. And the truth is, high quality data, or having control over your data quality increases the efficiency, your efficiency in hunting, and also the impact that your hunts can have on the broader security organization you work in. So an example of that is if your data is more consistent, that will reduce the time and complexity it takes you to go from a hunting hypothesis to data analysis. It's actually going to reduce how much time you spend collecting data and preparing data during a hunt. Similarly, if your data is measurably accurate and measurably complete, that's going to improve the trust you have in your analysis. And it should also improve the trust you have in others' analysis, and maybe if you're a leader, the trust you have in your team's analysis. The third benefit I think is really interesting, and it's really important to call this out, is that we don't hunt in isolation. You're always hunting usually within the broader sense of a security organization. So you work alongside detection engineers, incident responders, maybe you have a 24/7 SOC, whatever it may be. When you have high quality data or can get control of your data quality, it can increase the impact that your hunts have on all those other groups, which is a really amazing capability to have. So when you have this capability, it makes it easier to collaboratively share content across those groups, as well as to drive impact from hunts in cooperatively improving the data quality for everyone. And there's going to be examples of that later in the presentation. So, that's why I think you want high quality data, or at least that's why I want it. But we don't all have it, and it's pretty hard to get. So how do you know when you don't have high quality data, you maybe have low quality data or data that can be improved? Well, there's a number of warning signs you can look out for. The ones I really like on this list include the second line, which is when you can't find data that is there. It's usually an indication that you have a data quality problem. A good example of this is, let's say you have endpoint monitoring software on your laptop and you make a remote connection to a remote server. And then you take that information, you go to your event logs, search for it, and you can't find it. That's an indication that you could have a problem with your data. So it could be that the information wasn't extracted from your laptop correctly. Maybe the data never made it to your log analysis platform. Maybe your log analysis platform miscategorized the data somehow. Whatever it may be, there's like quite a few things that can go wrong. It's a sign that the data quality isn't what it should have been. The last warning sign is really interesting because I think this is the one that we, when we hunt, we run into the most commonly. And that's when you spend more time during a hunt preparing data for the hunt than you do actually analyzing the data on the hunt. And this one's so common that I actually want to call it out specifically because I see this on every hunt I do, basically. I call this ad hoc data preparation, and it usually makes itself known in one of three ways. If you've ever had to convert data on a hunt before you could actually use it, that's a sign of ad hoc data prep. So CSV to JSON, XML to JSON, CSV to XML if you're crazy. That's a sign that the data wasn't ready for you on the hunt. The second example is if you've ever had to slice or manipulate fields and their values on a hunt to get at to create new data sets for a hunt. Great example of this is if you use regular expressions to extract substrings from the data you have on a hunt. That's another example of ad hoc data prep. And then the third one is if you've ever had to add context after you've collected data on a hunt. So for example, let's say you're hunting and the theme is identification of command and control servers, and your data set is network data. So you have lists of client IP addresses connecting to server IP addresses. Well, wouldn't it be great if those server IP addresses were resolved to the DNS domain that they resolved to at the time of the connections you were looking at? It's really easy to do that for one server on a hunt. It's a little harder to do it for 1,000. And it's really hard to do that for 100,000 servers if your data set on a hunt is that big. And you can automate that on a hunt. You can take the time to write a script, debug it, make sure it's outputting data in the right format. But that's time taken away from time you could be spent actually analyzing the data. So these are all signs that you're performing what are essentially data engineering operations or tasks during a hunt, and it's slowing you down from getting to the analysis and the results you want. The thing I'll call out about this is that, if you're finding yourself doing this type of work a lot, especially the same kinds of ad hoc data prep tasks across many hunts, it's a definite sign that you have data quality issues that you can improve or should want to improve. So then the question becomes, how can we actually make those improvements? Like what is the solution to this problem? So what's interesting is that the answer to this question is really simple, and it's also extremely complex. So the simple answer is you need a data pipeline. The complexity comes in how you architect that pipeline, design the pipeline, and actually use it. So this is where this talk is actually going to turn a corner and become a talk more about data engineering and how that impacts hunting and security operations, and why you really want to get control of your data with a pipeline. I want to say a few things about data pipelines before we kind of walk through this and what this means and the impact on hunting. But the first thing is that if you have no idea what this diagram is trying to tell you, all you really need to know about data pipelines is that they're processes for moving data from one location to another. So in this diagram, what you see on the left are sources of data like servers and services and HTTP clients, and they send data into the pipeline, and that data gets loaded into a SIM or a data warehouse or machine learning applications, whatever it may be. That's all a data pipeline is. The other thing that's interesting about data pipelines is that you definitely have one. Even if you don't know that you do, you absolutely have one. Great example is, if you pay a vendor to use their SIM, they give you tools to extract data from your servers to ingest into the SIM. They give you integrations to integrate services to extract data into the SIM. Those are components of data pipelines. They also give you, features to extract the data when it's being ingested and map it into fields. Maybe they even give you a common information model to map your data into. Those are all aspects of a data pipeline. You just maybe don't know you have one. The thing I want to advocate for at this point is that you can really get control if you focus on getting control of your data by building and maintaining your own data pipeline. It really accelerates your use cases, not only in hunting, but also across your entire security operations organization. Last thing I'll say about data pipelines at this stage is that this is the design we use at Brex for our data pipeline. The team at Brex is really small. It's 3 people. That includes me. We're responsible for all detection and response operations, plus we manage this system. And even on a team of 3 people, we find this to be immensely valuable. I've also worked at other places that have a similar design for their data pipelines, much larger than Brex. And I'm confident that this design can scale to event volumes of any size, events of any size, and essentially teams of any size. So this design could become your end-all design for your pipeline system. Now, with all that said, we're going to talk about pipelines from with these 4 areas in mind. So if you're thinking about building a pipeline or you maintain a pipeline today, you really want to focus on availability, consistency, timeliness, and completeness of your data. So what does all that mean? We're gonna take this bit by bit. Availability is possibly the most important part of this, and it is the thing that actually gives you most of the benefits that I talked about earlier. What's highlighted here on the diagram are 2, you can think of them as event streaming systems or event databases. They're labeled raw events and processed events. Essentially, how the data flows through the system is that the data comes from the sources, they flow into the raw event stream. That's unmodified, untouched data that is, quote, like you can think of it as being tapped from the source. That then flows into a process of decoration and normalization, which produces processed events. We're going to talk about what that means in a little more detail later. And then from that event stream is where most of your core security use cases are applied. So that's where your SIM pulls data from, your data warehouse, your machine learning analytics. It's a consistent data set. That's really important. So what this design does is it gives you availability in 2 senses. One is it gives you availability of multiple types of data. So you might store that raw unprocessed data long-term for event archival purposes, maybe for audit and compliance purposes. It's a really great use case for that. And then the process data is where you attach the sim, the warehouse, and machine learning applications. So your teams all work from a common set of data. So the other part of availability is, how those applications interact with the data and the like concurrent access they get to that data. For example, in this design, you could send half the data to your sim, maybe your detection engineers and your SOC work there. You could send all of the data to your data warehouse. Maybe your hunters work there and they use Jupyter notebooks to process that data and hunt through it. And then maybe 5% or a small percent of that data goes into machine learning analytics that the team has written. The part of this that really becomes beneficial is in all those teams working from the same process, which is formatted, normalized, decorated data. So this is the thing that accelerates the collaboration between groups, where any searches or data queries run in the warehouse can be shared with folks who are working in the sim. And even though those tools are different, there's minimal translation that needs to happen to actually get the queries working in other systems, because you're all working from the same data sets. The other thing that's interesting is that, let's say you're hunting and you're running, you're building a notebook in Jupyter and you're in the data warehouse, and you come up with a really cool new way to transform the data. Like maybe it's a new regular expression you use to extract some high value fields from other unprocessed fields that are in your data set. Well, you could keep that there and only ever run it in your notebook and isolate that knowledge and that data to just the hunt team, or you could commit it back into the data pipeline and make that that new process data available for everyone at scale. And that's the value of cooperatively improving data with a system like this. You can take innovations made in what appear to be isolation during a hunt in the data warehouse and actually level up the capabilities of the sim and the folks working on machine learning at the same time. It's really powerful to be able to do that at scale. The second focus area is data consistency. And I think this is the one that most folks are going to be familiar with. This is a process that sits between the raw event stream and the processed event stream. And it is the process that actually turns raw events into processed events. So what we're talking about here are three things. It's consistently formatting, normalizing, and decorating data. And again, you want to do this across every data set you handle, and you can do this at scale with a pipeline design like this. Formatting data is pretty simple to understand. You convert data from, say, CSV to JSON. At Brex, everything becomes JSON. When you pull from our processed event stream, you're guaranteed to get compliant JSON data. You won't ever get anything else. For normalizing, this is when we start to think about common information models. So a common information model, just in case anyone's not unfamiliar with it, is essentially a way to map similar field values across different data sets to one field value. So imagine all of the different data sets you have that describe source IP addresses. And wouldn't it be great if instead of searching all those unique fields, you could search one field? Maybe it's called source_IP, and that's how you run your searches. That's an example of what a common information model can give you. The important thing about common information models and hunting that I've learned is that you really want to prefer unified permissive schemas with your models. There's two parts to that. So a unified schema means that the data from a single event or a single data set isn't being spread across multiple models. For example, take a EDR network connection event that you might observe. That's going to contain up to 3 types of distinct data in it. It'll contain host data, so information about the system it came from, the network data, so that's the network connection, and process data about the process that was responsible for the connection. If you had a non-unified or separated models, you might have a network model, and you might have a process model, and you might have a host model, and that's really not conducive to good hunting. Hunts are so dynamic, you usually need all that data in one location that's easily accessible and understood. The second half of it is the permissive side. So a permissive schema simply means you can update it to fit your use cases. And that becomes really important if you hunt on a regular schedule or have a cadence for hunting. because that means it's more likely that you're going to outpace, your use cases are going to start to outpace the value you get out of a restricted schema, which is one you can't update. This is actually where a lot of vendors kind of fail. They give you a schema that is rigidly defined, you can't update it. And as soon as you need to map a new data set to that schema, you can't. So when you're hunting, you really want to identify opportunities to get unified permissive schemas in place. Third part of consistency is decoration of data. This is the hardest to achieve in practice, but it's not impossible. And this is when you enrich your data with external and internal context. So the example from earlier, take a server IP address, resolve it to the DNS domain at the time you observe the event. That's an example of decoration. And you can definitely do it at scale with a system like this in real time. Third focus area, timeliness of data. This essentially describes how fast data moves through the entire system, also how fast it needs to move, and then how long you retain that data once it's moved through the system and loaded into the downstream platforms. So for example, data starts at an HTTP client, flows through the system, gets loaded into your SIM. There's two components to this. There's retention and speed, essentially. And you can think of this as two questions you ask yourself. One is, how long should you keep your data? The other is, how soon does your data need to arrive? With emphasis on need and not how fast it can arrive, because you can make data move really fast. To answer those questions, I think you really want to focus on the what, how, and who of your use cases. So the what refers to the type of data you're dealing with. The how refers to the kinds of analysis you do on the data. Those would be your core use cases for the data. And the who refers to who's using the data. It's your end users. It could also include your staffing model. So do you have a 24/7 SOC? Do you have a 12/5 SOC? You know, the example of this is, for example, say you have a 24/7 SOC, they process endpoint EDR data and they analyze it in real time. Well, you probably want that data to arrive pretty fast, like within minutes, and you probably want to retain it for a long time. Retention would be important for supporting long tail security investigations and incidents that you aren't notified of, maybe until months after the initial intrusion. Compare that to a use case where you do once a month ad hoc data searches through your service audit logs. Does it matter if that data arrives within minutes? Probably not. It probably could arrive within tens of minutes or an hour and you wouldn't even notice because your use case doesn't have a need for it to come to arrive that fast. The point I want to make about timeliness is that when you start to ask these questions and align your answers to your use cases, this is where you can save a lot of money, especially if you're paying for vendor solutions. Completeness is the last focus area. So this is usually observed at the source and the destination. So for example, on the server or in the data lake or data warehouse or SIM where the data is eventually loaded into. And like timeliness, this has two focus areas or two components to it. There's completeness in terms of coverage and completeness in terms of reliability. Also can be posed as questions. So for coverage, it's what % of systems deliver data successfully and how do you measure that? One technique that I like for measuring that is to take the data you are successfully ingesting into those, say your SIM or your data warehouse, and compare it against a trusted source of truth. So for example, if you wanted to validate that your EDR deployment was delivering data successfully, you could compare the hosts that are checking in that data against your inventory management tools or some other type of inventory you have. This actually is indirectly impactful on hunts because if you don't know what % of systems are delivering data successfully, it can impact your analysis and your conclusions. So if you hunted your EDR data set and you didn't know 15% of systems weren't sending the data, that becomes a reason you're going to need to rerun that hunt later to recheck your analysis. For reliability, the question becomes what % of data was delivered successfully, or what % is lost, what % is malformed when it arrives. And a way to check for that is to use labeled data that you emit into your data pipeline. It can be a production pipeline. And as long as the data is labeled correctly, you can track that as it progresses through the pipeline, and then check for it to come out on the other side. Um, if it comes out reliably on the other side, that's some assurance that the pipeline is working consistently and reliably. What's interesting is you can even do that with simulated attack data to test for regressions in your real-time detection and also regressions in your event parsing configurations. But if you do it with simulated attack data, just make sure it's well labeled and that all the systems and teams who could be impacted by it understand the labels, because you don't want to cause any false alarms when you send simulated attack data to the SOC or to your incident response team. So that's essentially where I'm gonna end this talk and leave it. I think the things I want you to take away from this and think about is, one, you have to actively think about improving data quality. It isn't, I'd say most of us don't intuitively understand the concept of low quality data and high quality data, although we run into it probably on every hunt we do. And once you actively start to think about it, then you're going to be motivated to fix it. And once you become motivated to fix it, and you can get commitment to fix it, you need to do two things. One is you need to monitor the data, not only for regression, but monitor for completeness, accuracy, a lot of the data dimensions that were mentioned at the beginning of this talk. You also need to just commit to continuously improving that data, because like a lot of things we do in security, data, you're not going to improve your data once and be done. The business is constantly shifting around you. Your use cases change. There's always opportunities to improve things like this. And finally, again, I want to advocate, you can really accelerate your use cases if you get control and own your own data with a self-managed data pipeline. I'll say again, the team at Brex is incredibly small, wide range of responsibility, and yet we put the time into doing this, and we get immense value out of it. So if you are, thinking about building your own data pipeline at this point, or you do manage your own data pipeline, I think the two areas I would recommend you start on are figuring out your use cases around availability of data and consistency of data. And this is where we can open it up for questions.
Thank you so much, Josh. I think, as you were going through your presentation, I was keeping an eye on Slack, and especially at the beginning when you were talking about some of the issues with data as far as, converting from XML, the data prep, people in the Slack channel were, wow, these slides are hitting really close to home. And I think kind of bullet pointing it all out and laying it out all right there really drives home that point of the data quality. And there's an active discussion going on, a lot of interesting things being said. I think you sparked some great conversations. And one of the questions here that I was able to pick out is, does this data normalization and formatting increase storage needs? What should be kept in mind when performing these activities?
That's a great question. It can definitely increase your storage needs. So you could see 20 to 25% increase in events if you do something like, for example, you take the raw event data and you append the modeled or normalized data to it. At that point, you want to start to think about the applications you're loading the data into. Maybe it's a reason why you don't put all of the data into your SIM. If it's very expensive for you to do that. And you might look at an alternative solution like storing all the data in a data warehouse, which would be much more affordable. There's other solutions too we can talk about in the Slack channel.
Great.